Hello there, welcome to the October 2020 paper 2. Here we're looking at question 4. Use de Moivre's theorem to prove this expression here. Now what we're going to be doing here is we're going to be expanding cos theta plus I sine theta to the power of 7 in two different ways. The first way we're going to be doing it is by expanding de Moivre's theorem. So it's going to be cos 7 theta plus I sine 7 theta. Now we're also going to expand this expression here with relation to the binomial expansion. We've got two expressions here we can expand using binomial expansion. So the first way of doing it, the way of doing it is going to be cos to the power of 7 theta plus 7 choose 1 cos to the 6 theta sine theta, I sine theta rather. And then it's going to be 7 choose 2 cos to the power of 4 theta I sine theta squared plus 7 choose 3 cos to the power of 3 theta. No, sorry, I've missed one. It should be a 5 here. This one should be a 4. 4 theta I sine theta to the power of 3. Plus 7 choose 4 cos cubed theta I sine theta to the power of 4 plus 7 choose 5 cos squared theta I sine theta to the power of 5, and then plus 7 choose 6 cos theta I sine theta to the power of 6, and then the final one will be I sine theta to the power of 7. Okay, so quite a big binomial expansion there. Now what we're only going to be doing here is we're just going to be comparing the imaginary parts on both expressions. So comparing imaginary parts. So comparing imaginary parts of z. So what I'm going to be doing here is I'm just going to be comparing stuff that has I in front of it. So that's going to be sine 7 theta equals, now this expression here won't have an I in front of it. This expression here would, so I need to now work out what 7 choose 1 is. 7 choose 1 is 7. So it's going to be 7 cos to the power of 6 theta sine theta with an I in front of it. We just drop the I. This bit here will not have an I in front of it because I squared will simplify to minus 1. This bit here will have an I in front of it, but given that it's I cubed, it's going to be minus I. So it's going to be minus 7 choose 3, which is 35. 35 cos to the power of 4 theta sine cubed theta, because the I is being cubed as well, so it's minus I, and we've dropped the I but kept the minus. This one here will not have an I in front of it because it's I to the power of 4. This bit here will have an I in front of it. Now I to the power of 5, that's back round to I, so it's going to be 7 choose 5, which is 21. So it'll be plus 21 cos squared theta, and then it's going to be sine to the power of 5 theta, and then the final bit is just minus sine to the power of 7 I, because I to the power of minus, so I to the power of 7 is I to the power of 7 is minus I. Right, okay, so now we need to just turn these causes into sines then. So it's going to be 7 brackets 1 minus sine squared theta cubed sine theta. And then it's going to be minus 35 1 minus sine squared theta squared times sine cubed theta. And then the next bit's going to be plus 21 1 minus sine squared theta, and then it's going to be sine to the power of 5 theta minus sine to the power of 7 theta. And now when we expand this, we're going to get 7 brackets, so we'll do some binomial expansion on this bit as well. So it's going to be 1 minus 3 sine theta plus 3 sine squared theta minus sine, sorry, not sine squared, it would be 1 sine squared, then 2 sine squareds, then 3 sine squareds, sine theta. And then it's going to be minus 35 bracket 1 minus 2 sine squared theta plus sine to the power of 4 theta times by sine cubed theta. Then the next bit's going to be plus 21 1 minus sine squared theta times sine to the power of 5 theta. And the next bit's going to be minus sine to the power of 7 theta. Okay, so when we expand all of this, we get 7 times 1 times sine theta, so that's 7 sine theta. And that's the only sine theta on the page, actually. And then it's going to be minus 21 sine squared, sine cubed actually, so minus 21 and another minus 35 sine cubed, and no more down here, so that will give us minus 21 minus another 35, that will give us minus 56 sine cubed theta. Then the next bit's going to be 21 sine cubed and minus 35 times 2 sine to the power of 5. Oh, so it's sine to the power of 5 now, so it's 21 plus 70, and then it's going to be plus 21, so that will give us 112 sine to the power of 5 theta. And then the last bit is going to be minus 7 sine to the 7 plus, so minus 35 and minus 21 and minus another 1, so that would be minus 64 sine to the power of 7. And there we are, that's our expression that we're looking to prove it's equal to. So there we are, so sine to the power of sine 7 theta, sine 7 theta equals this expression here. So there we are, that's part A. Okay, so part B is hence find the distinct roots of the equation 1 plus 7x minus 56x cubed plus 112x to the power of 5 minus 64x to the power of 7 equals 0, giving your answer to 3 decimal places where appropriate. Now, if I substitute in x equals sine theta, then all of this expression here will turn into the equation we had before, so then the whole thing basically becomes 1 plus sine 7 theta equals 0. So therefore sine of 7 theta will equal minus 1, and let's just assume that our theta range is initially in between 0 to 2 pi, then 7 theta is going to be in between 2 pi to, so it's 14 pi rather, to 0. So it's going to be 7 theta equals, so to equal minus 1 on the sine function, it's going to be 3 pi by 2, so 3 pi by 2. And then I can just add 2 pi to get more solutions. So it's going to be 7 pi by 2. Add another 4 pi by 2, that would be 11 pi by 2. Add another 4 pi by 2, that would be 15 pi by 2. Add another 4 pi by 2, that would be 19 pi by 2. Add another 4 pi by 2, that would be 23 pi by 2. Add another 4 pi, that would be 27 pi by 2. And I think we have to stop there. So therefore now theta is going to equal 3 pi divided by 14, 7 pi divided by 14, 11 pi divided by 14, and 15 pi divided by 14, and 19 pi divided by 14, and 23 pi divided by 14, and 27 pi divided by 14. So now we know what the value theta needs to equal. Now we just need to sign all of these values to get the values of x. So let's go grab our calculator then and type all of these values into the calculator. So 3 pi by 14 will give you 0.623 to 3 decimal places. Sine 7 pi by 14 is just give you 1. Sine 11 pi by 14 will give you again 0.623. Sine 15 pi by 14 will give you minus 0.223. Sine 19 pi by 14 gives you minus 0.901. Sine 23 pi by 14 gives you minus 0.901. And sine 27 pi by 14 gives you minus 223. So therefore we've got some repeated roots, yes, but our final answers here are 0.623, 1, minus 0.223, and minus 0.901. So there we are, that's the answer to part B, and that's the answer to question 4, worth 10 marks in total there. Let's now move on to question 5.